Hello, in this screencast, I'm going to walk you through my Python program called the nature of numbers. I'll explain what each line of code does in simple terms. Import month. This line brings in Python's math library. We use it later to calculate square roots. Play again. Play underscore again is equal to true. Here, I make a variable called play underscore again. It starts as true, which means we want to keep running the program. This will control our loop. While play underscore again, this starts a while loop. It keeps repeating the program as long as play underscore again stays true. This is a comment. Number is equal to int in bracket, input in bracket, enter a whole number, i.e. an integer. This line asks the user to type in a number. This prompt here. The int part, this one, makes sure that whatever the user types is treated as a whole number. This prints back the number that the user enters so they can see what they typed. We'll move to this block. Determine if number is even or odd. This is a comment here. This block checks if the number is even or odd. The percentage sign means remainder. If the number divides evenly by 2, it's even. If not, it's odd. So the first print will print even, else it will print odd number. Move to this block. There is a comment here to do. Determine if number has perfect square root. This one, if number is greater than or is equal to 0, checks whether the number is 0 or positive. We do this because taking a square root of a negative number with math.square will cause an error. In this program, we only handle real square roots. If the number is negative, the code jumps to the else at the bottom and prints a message. Root is equals to math.square in bracket number. This one calculates the square root of a number and stores it in the root. Root is a float point number, e.g. math square 9 will give us 3.0. Math square 2 will give us 1.4, 142, 1356. Move to this one. If int root in bracket root is equals to root, int root removes any decimal part, truncates. This line compares the truncated value to the original value. If they are equal, root has no fraction part, meaning the square root is a whole number, a perfect square. We'll move to the next line, line number 25. Runs when the test is true. It prints a friendly message and shows the square root as an integer. So you see 3 instead of 3.0. Move to the else, the inner else. Runs when the square root is not a whole number. It prints the number does not have a perfect square root. Move to the else, the outer else. This matches the very first if number is greater than or equal to 0. If the number was negative, this line executes and prints negative number does not have real square roots. This one is a comment to do determine all factors of number. This line here, factor is equals to the brackets here. We create an empty list called factors. This will store all the numbers that evenly divided into our chosen number. Line 34, for f in range, open bracket 1, comma number plus 1. Here we start a loop that checks every number from 1 up to number, including numbers itself. Each time the variable f takes one of these values. Example, if a number is equals to 12, then f will be 1, 2, 3, all the way to 12. Line number 35. This checks whether f is a factor of a number. Percentage is the module operator, which gives the remainder of division. If dividing number by f leaves no remainder is equals to 0, then f is a factor. We move to line 36. Factors dot append f. If the test was true, we add append that number f into our list of factors. We move to line 37. Finally, we print our friendly message. Map in brackets string, comma factors, turns the numbers into text, strings. This one here, join in bracket map string factors, puts them together separated by commas. Even if a number is equals to 12, the list is 1, 2, 3, 4, 6, 12. Message prints. The factors of 12 are 1, 2, 3, 4, 6, 12. There is a comment here. Ask user if they want to play again. Line 40. This line asks the user a question. Input pauses the program and waits for the user to type something. The message shown is Would you like to enter another number? Yes or no? The answer like Y or no is stored in a variable called again. This one here. The answer, okay. The /n at the start just adds a blank line before this question to make the output looks cleaner. We move to line 41. If again dot lower is equals to n. Here we check whether the user typed. Dot lower makes sure that no matter if they type n, capital N, or small n, or even no, it turns into lowercase for comparison. If the answer is actually n, then we know they don't want to continue. We move to the next line. Play again is equals to false. If the user said n for no, we set the variable play underscore again to false. This tells the program to stop the loop, because earlier we probably had a while play the again loop running. Print, open the bracket, thank you for playing. Finally, we print a polite message saying goodbye, thank you for playing. And that's the entire program, explaining line by line. In short, it asks for a number, tells you if it's even or odd, checks if as a perfect square root, lists its factors, and then asks if you want to continue. We can do a test. We move to the terminal. Let's put number 20. Okay, when the program starts, it will ask you enter a whole number, i.e. an integer. We put 20, enter. The program will give you the number you entered is 20. 20 is an even number. 20 does not have a perfect square root. The factors of 20 are 1, 2, 4, 5, 10, and 20. Then it will ask you, will you like to enter another number? We'll say yes. We'll print Y for yes, then enter. Then it will ask you to enter a whole number. Let's put 16, then enter. The number you entered is 16. 16 is an even number. 16 has a perfect square root, which is 4. The factor of 16 are 1, 2, 4, 8, and 16. Then the program will ask you again, would you like to enter another number? Now we'll say no by tapping N, then enter. The program will tell you thank you for playing. That marks the end of the presentation. Thank you for watching.